Good day, guys. Welcome back to our YouTube channel. So, this is Stiffler, and Stiffler is me. You know how it goes, guys. So, today I'm here to start with this topic, the mechanical energy in grade 10. What happened is that some guys approached me to do the work, energy, and power. They said it is the most difficult topic. Actually, the work, energy, and power is a grade 12 topic. So I was like, okay, guys, if I would start with this topic, it means that I must give you the good basics, because every topic deserves the best basics. If you can understand the basics, you can be so much good with any topic. You can be so much good to work with this concept. So I was like, okay, I'll start with the basics, which the basics are handled in grade 10 in the topic called mechanical energy. So mechanical energy is the topic that I'm going to start with today, guys, and I will just try to show you the basic types of energies that you require in grade 12 work, right? So here we are, mechanical energy, right? So we'll be talking about energy, guys. So when we ask many times what is energy, people say energy is the ability to do work, and which they are not wrong about it. It is the ability to do work, that is energy. But what is energy actually? Energy is it was derived from a Greek word. When you translate it, it means activity or it means operation, so which is directly linked to work, right? So when you're doing activity, you're actually doing work. So each and every object in the universe, guys, has energy. Each and every particle in the universe has energy, right? So each and every particle in the universe has energy. Each and every particle has energy. So energy is closely linked to mass. So it is closely linked to mass. So it means that it also makes sense, like bigger objects or energy with higher masses, higher energies, right? So energy is closely linked to mass. But anyway, we are going to talk about the different types of energy as far as grade 10 work is concerned. We are going to talk about energies, right? So energy cannot be created or destroyed, right? You cannot create energy and you cannot destroy energy. Energy can rather be transformed from one form to the other, or it can be transferred from one object to the other. No one can actually create energy or destroy energy, right? So it can be transformed from one form to the other, or it can be transferred from one object to the other, right? That is how we can get the energies, right? So in grade 10, we deal with what is called potential energy. Potential energy. Potential energy. So what is potential energy really? What is potential energy? There are different types of potential energy, right? So potential energy, when we're describing what is potential energy, we say potential energy, it is the energy an object has due to its position or state, that is potential energy. The energy an object has due to its position or due to its state, right? So how many types of potential energy do we know, or do we talk about mostly in physical science? We talk about chemical potential energy, and we also talk about electrical potential energy, right? And we also talk about this type of energy that we talk about throughout in this topic, which is called the gravitational potential energy. So this is the energy that we're going to talk about mostly in this topic, the gravitational potential energy. So this is how we are going to start this topic to prepare for the work, energy, and power in grade 12. So it means that to the grade 10s watching this, you have to be you have to take this topic so much important because it gives you the background to the work energy and power in grade 12. And work energy and power is a very, very, very complicated topic, but easy when you understand the basics. I think every topic is just easy when you understand the basics, right? So let's just get into it to see what is the gravitational potential energy. And mostly in this topic, we refer to the gravitational potential energy as just potential energy, right? So we refer to it mostly as potential energy. So let's get to it and see what's really going to happen. So the gravitational potential energy, it is also shown by EP. We're not talking about physics, guys. We're not talking about the energies. So we show it by just saying EP. So what is the gravitational potential energy? This is the energy an object has due to its position in the gravitational field. So this deals mostly about the position that the object is at, right? So it means that if you're taking a look at two objects, the one that is here on the high at the top of the building, that is 5 meters, and the one that is here on the ground. So find that this object that is here on top, it is having EP because it is somewhere on top of the building that is higher up above the what? Above the ground. So this is the position on the gravitational field. So it means that this one is 5 meters above and this one is on top of the ground, so which is 0 meters above. So we find out that this object is having potential energy. So this energy, this object on top will have potential energy, right? And this one below here, it won't have any potential energy, right? So that is how we can describe the potential energy. I hope you can see what is happening here. So it means that this object here is having potential energy and this one is not having potential energy according to the situation that we are given, right? So that is potential energy. And energy, each and every energy is measured in joules, right? It is measured in joules, or we can just write J like that. So how do you calculate potential energy? So calculating potential energy, we use EP, as I said, EP representing potential energy, gravitational potential energy. We say this is equals to mg then h, where m, this is the mass of the object in kgs, right? And this is the gravitational acceleration, which is constant. So this is the constant, it is the given value, meters per square second. So this is the gravitational acceleration, and this height, it is the perpendicular height above the ground. So this is the perpendicular height above the ground, and it is measured in meters. So we're having kgs, meters per square second, and another meter. So kg, meter, and another meter, and per square second, right? So this is how we can measure, how we can calculate the potential energy. EP is equals to mgh. This is the formula that you can use to calculate the gravitational potential energy, right? So having said that, let's just try to take a look at an example that can help us to calculate the gravitational potential energy. Trust me, guys, this is simple, but it is also important. So get the basics right? So gravitational potential energy, energy an object has due to its position in the gravitational field. How do you calculate it? EP is equals to mgh. So it's just simple. EP is equals to mgh. So let's try to take a look at an example and try to calculate this. So here comes the example that says calculate the potential energy at A, B, and C. So we're seeing there that we're having an object. That object, it is 10 kgs, and it is on top of the 25-meter high building. So the A position is on top of this building, and the B position is when it is somewhere 5 meters above the ground, and then the C position is on the zero ground. This is on the ground straight, so this is the zero reference point. So they said we must calculate the potential energy of those of that object at different positions, right? So to start with, to calculate the A1, right? So we say EP at A will be equals to mgh, which will be equals to the mass, it is 10 kg. Gravitational acceleration, we said it is constant, which is 9.8, and our height there, it is 25 meters, right? So when you're calculating this, when you plug into the calculator, we're going to get 2450 joules. So this is the potential energy at point A, right? So let's try to see the potential energy at point B. The potential energy at point B. So at point B, our EP at B will be equals to mgh, which is also equals to the mass, which is 10, the gravitational acceleration 9.8, and the height there, it is 5 meters. So when we're putting everything together in the calculator, we're going to get 490 joules. So the potential energy now at point B, it is 490 joules, right? And now when we're looking at point C now, when we're looking at point C, that point C, it is at the 0 ground reference. So it means that our potential energy there will be equals to mgh, which is 10 multiplied by 9.8 multiplied by 0. So it means that our potential energy at point C, it is 0 joules. So any object that is at the ground level is not having any potential energy, or we can say its potential energy is 0, right? Its potential energy is 0. Okay, so now that we've talked about potential energy, now we can talk about kinetic energy, right? Kinetic energy. So what is kinetic energy now? So as you can see, the topic is about mechanical energy, so it is also important to talk about kinetic energy after talking about potential energy. So what is kinetic energy? So this kinetic energy is the energy an object has due to its motion. So this is the energy an object, this is the object, an object have due to its motion. So what do we talk about when we're talking about motion? When we talk about motion, mostly we talk about the speed, we talk about the velocity, right? So this is again measured in joules, just like any other energy. Energies are measured in joules. So how do you calculate this kinetic energy? Kinetic energy is calculated by using EK is equals to half mv squared. So let's see again. So this m, it is the mass in kgs, and this v squared, it is the velocity in meters per second. So having the mass in kg, the velocity in meters per second, and half is just half. We know what is half, right? So this is how we can calculate the kinetic energy. The energy an object has due to its motion, right? So now we've talked about two types of energy. Now we've talked about potential energy and now kinetic energy. So this is the energy an object has due to its motion, right? Due to its motion. So let's take a look at an example how we can calculate the kinetic energy. So in this example, they said a 10 kg car traveling at 18 meters per second and slowed down to 5 meters per second. After some time, it stopped. Calculate the kinetic energy at 3 different situations. So we're trying to calculate the key EK at 3 different situations. So it means that our situation number 1, it is this one, it is traveling at 18 meters per second. And then the second situation is when it is traveling at 5 meters per second. And the last one is when it is stopped. So it means that when it is stopped, our velocity is equal to 0 meters per second. So how can we calculate kinetic energy on those 3 different events, right? So again, we'll start by saying E K is equal to half mv squared. So this is the what? This is the formula. You always have to write the formula. Half mv squared, right? So this will be equals to half. What is the mass of this object? It is 10 kg. So this is 10, and the velocity to start with, it was 18 squared. So when you get the situation like this, punch in our calculator, and then we find that our kinetic energy there, it was 1620 joules. So that is the kinetic energy at the first situation. And then we can move to the second situation, and again, don't forget that our EK is equals to half mv squared. So again, this will be half, and then 10, and then our velocity is 5 there, so it will be 5 squared. So when we punch everything together, we're going to get 125 joules as our second situation, right? And then lastly, our third situation, when the car is stopped, our EK is equals to half mv squared. So this is again half, and then the mass is 10, and then the velocity there, it is 0 being squared. So 0 squared gives us 0, so it means that our kinetic energy there, it is 0 joules. So now it means that you can see what is trying to happen between the kinetic energy and potential energy. So it means that with the potential energy, when the object is on the ground, its potential energy is 0, right? When it is at the maximum height, its potential energy is maximum, right? And with the kinetic energy, when the object is not moving, then its kinetic energy is 0. But when it is at a maximum velocity, we have its maximum kinetic energy, right? So now that we've talked about kinetic energy and potential energy, let me just give you the checkpoint 1 and the checkpoint 2 that we'll view once you're doing the checkpoint questions, right? So can you please, you can just take a screenshot of this checkpoint 1. So again, just like every time, I'll post this so that you can have a look at your spare time. I'll leave the link in the description again. So this is checkpoint 1. This is talking about potential energy only. I hope you took a screenshot. And now the checkpoint 2, it is focusing on kinetic energy. So this checkpoint 2 is focusing on kinetic energy. You can also take a screenshot of this before we can move on. Okay, I hope you took a screenshot. Okay, so now that we've talked about kinetic energy and potential energy, so now let's talk about mechanical energy. So what is mechanical energy? So mechanical energy, it is simply the sum of kinetic energy and potential energy of an object at any given time. That is mechanical energy, the sum of kinetic energy and potential energy at any given time, right? At any given time, the mechanical energy can be described in that way. So it means that we can show that by saying EM is equals to EK plus EP, right? That is mechanical energy. And you know what is EK? EK is half mv squared, and this is mgh. So this is how we can calculate the mechanical energy, and still it is still in joules, right? It is still in joules. That is how we can calculate the mechanical energy of an object at any given point, right? So let's try to take a look at an example that is given here. So don't forget that we said EM is equals to EK plus EP, right? So again, this is our situation that we're having. They said a 20 kg ball is on a tall 30-meter bridge above the ground, traveling at 5 meters per second, right? So the questions comes and then they say calculate the EP, the EK, calculate the EP, and lastly calculate the EM, right, of this object. So it means that our first thing first, we can calculate the EK, which you say EK is equals to half mv squared, which will be half 20 and 5 squared. That is how we can calculate our EK, right? That is how we can calculate our EK and find that this is 250 joules, right? And the next thing they say calculate the EP. So we know that the EP is equals to mgh. So this is the mass, which is 20 gravitational acceleration, which is 9.8. to say this is a constant, 9.8, and then the height is 30 meters. So find out that the EP there, it is 5,880 joules, right? And then lastly, they said we must calculate the EM. And we said that our EM is equals to EK plus EP. So already we found our EK there and already we found our EP there, right? So it means that we can simply say this is 250 plus 5,880, right? So it means that our EM now becomes 6,130 joules. So this is our mechanical energy of this object at this given time, at this given instant. That is our mechanical energy, right? So now mechanical energy now becomes so much interesting because we're going to talk about different laws in physical science, the laws that we're going to use even in grade 12 or even beyond that, right? Yes. So after knowing the mechanical energy, so now let's talk about the laws that we're going to use. So as I said, we're going to use the law of conservation of energy. The law of conservation of energy. Why do we start on the law of conservation of energy? So that we must know this, it must be in our thoughts that energy cannot be created or destroyed, right? So energy cannot be created or destroyed. It is merely changed from one form to the other. So energy can just be changed from one form to the other, but you cannot create it or destroy the energy, right? So energy cannot be created or destroyed, but it can be transformed from one form to the other, or it can be transferred from one object to the other, right? So when we're talking about mechanical energy, for instance, right? We're talking about mechanical energy. So mechanical energy, you know that there's EK plus EP, or we can say EK and EP, right? That is our mechanical energy. So in this situation, it means that if we're having an object that is traveling at different heights and also different velocities, so it means that our EK at some other point, it is changed to be EP, or it can be transformed to be transformed into EP, or sometimes EP can be transformed into EK, and so on and so on and so on, right? So it means that the energies can be changed the forms from being one form to the other depending on the situation, right? So this gives rise now to the law that you are mostly interested in, that you are going to deal with now and also in grade 12 and also beyond, if you're interested in anything that has to do with mechanics. Mechanics is a very, 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 very interesting topic, but it can get complicated if you miss the basic concepts, right? So that's why I'm always telling you that it is important to get the important concepts, right? So let's get into the law of conservation of mechanical energy now, right? So the law of conservation of mechanical energy. The law of conservation of mechanical energy, it says that the total amount of mechanical energy, remember what we said, what is mechanical energy? We said it is EK and EP added together, right? So they said the total amount of mechanical energy in a closed system. So a closed system, you can also refer to it as an isolated system, remains constant or it is conserved. So you can say it remains constant or it is conserved, right? So it remains the same. So it means that, what is this trying to say actually? This is very, very simple, guys. So it means that if we're having an object that is traveling through different points, right? So I said this is point A and this is point B, right? If this is an isolated system, or before we can go there, let's try to describe what is an isolated system or a closed system. So an isolated system, it is a system that we describe as there are no external force acting on the system, no external forces. So there are no frictional force, there's no air resistance, there are no any other type of or even applied force. There's no applied force. So the only force that is acting on this, it is only gravitational force. So in this grade 10 work, if you're in grade 10, don't worry about that. You worry mostly about that when you get to grade 11 when you're doing the forces, right? But this is the situation. In grade 10, they will just tell you that it is a closed system or an isolated system, or there are no frictional force or whatsoever that they will tell you. But if they tell you that, know that the law of conservation of mechanical energy is going to be in play now, right? So now I said, if you're having 2 points, point A and point B, if this is an isolated system or a closed system, right? So it means that the mechanical energy at point A, if you calculate the mechanical energy, like we said, the mechanical energy, it is EK at A plus EP at A. If you add the two, you find that they're also equal to this of this object B. So it means that also here EM at point B will be equals to EM at point A. So it means that our EK at B plus our EP at B, they're exactly the same as our EK at A and our EP at A, right? So what does this tell us now in terms of physics? What does it tell us now? It tells us that no matter where you go in this loop, if the mechanical energy is conserved, or if this is an isolated system, it means that our mechanical energy is conserved. So if this is the case, they will leave us with the equation like this. So this leaves us with this EM at A is equals to EM at B, right? So what is EM? EM is EK at A plus EP at A being equals to EK at B plus EP at B. But what is this? This is half mv squared at A plus mgh at A will be equals to half mv squared at B plus mgh at B. So this is the situation we are going to have now, right? So this is the law of conservation of mechanical energy, right? So it means that if you're having one unknown here, it's either you don't have the height of this building, but you're having the mechanical energy here and the velocity here. It means that you can calculate the height of this building using this formula here that we are having. So this is called the law of conservation of mechanical energy. We can use it back and forth, just to try to find whatever that we are trying to find, right? So don't worry for now. We'll do the example like always so that you can see what you can do or how you can use this formula, right? But this is called the law of conservation of mechanical energy, right? So let's try to see and let's try to check at the example, right? So we're having this situation there. We're having point A there. So this is our point A. That is 50 meters above the ground. So there's a ball that is there. Its initial velocity is 0. So it was dropped from that position. So its initial velocity is 0. So this ball moved up until it got to B, right? And when it got to B, we don't know its final velocity there at B, right? So we're trying to calculate the final velocity at B. So how can we do that? So we can also use the same situation of EM at A is equals to EM at B. The mechanical energies should be the same, right? So again, we are going to use half mv squared at A plus mgh at A should be equals to half mv squared at B plus mgh at B, right? So this becomes half, what is the mass? It is 30 kg, and the velocity there at A, it was 0, so 0 squared plus the mass there, it is still 30, 9.8, and the height there, it is 50 meters, right? Being equals to half, the mass there, it is still 30, and the velocity there is what? Is, we are looking for it, so it's velocity squared at B, right? And also mgh at this side, right? So what is the mgh at this side? We can see that the height here at point B, it is 0, so this becomes 0, so everything here multiplied, it becomes 0, right? So here again, this gives us 0, sorry about that, so it's 0 plus, and if you punch this inside the calculator, we're going to get being equals to, and this becomes, what is the half of 50? So is it, oh, the half of 30, so this is 15 v squared at B, and already that gave us a 0, so it's plus 0, right? So now we're just trying to use basic algebra equation to calculate the velocity at B, right? So we can divide throughout by 15. So if you divide throughout by 15, we can see that our v squared at point B is equals to 980. So now we can just do the square roots, right? So it means that our v at point B will be equals to 31.30 meters per second. So it means that this, when it go to point B, it was having 31.30 meters per second. So this is how we can use the law of conservation of mechanical energy. The law of conservation of mechanical energy. The question is, are you able to do that? Are you also able to calculate that? So having said that, I will leave the link to the questions that you can also try to do based on this mechanical energy. And also, you know that after doing this work, we are going to I'm going to give you the solutions to the questions. So these questions on this checkpoint, the last checkpoint, what is going to happen is that I just compiled the question papers, the final question papers of grade 10 work, that is having all the work, right? So I will just leave the link in the description so that you can go to my Google Drive and download that so that you can work on that. And then when I come back next time, I'm going to do the solutions to that video, right? So I think that is all that you need to know about grade 10 mechanical energy. I hope you enjoyed, guys. If you've enjoyed, please share, like, and subscribe if you haven't subscribed. Thank you for watching. See you on the next one.